Welcome to Computational Intelligence and Decision Support. This is our team, Nihal Mahmoud, Roghda Mohammed, Nada Abdelkader. Today we're going to talk about the difference or contrast between theory, hypothesis, and model. But first we need to know the definition of each of them. So first, what's meant by theory? A theory is a well-established principle that has been developed to explain some aspect of the natural world. A theory arises from repeated observation and testing and incorporates facts, laws, predictions, and tested hypotheses that are widely accepted. So mainly, a theory is a principle developed to explain an aspect in the natural world, and it depends on testing and repeated observation. Then, what is hypothesis? What's meant by hypothesis? A suggested explanation for an observable phenomenon, or a reasoned prediction of a possible causal correlation among multiple phenomena, and it is a speculative guess that has yet to be tested. So it's a guess or a suggestion that still has to be tested, so it's not yet tested. What's a model? Models provide possible explanations for natural phenomena, so it deals with nature, natural phenomena. Now, after understanding the meaning of each, we have to know the difference between each, or the contrast between them. First, we need to know the difference between hypothesis and model because they're quite same. There's not usually any difference between hypothesis and model. Model is basically our hypothesis of nature, as we said, of the nature of phenomena. However, not every hypothesis needs to be a model. Some hypotheses are not related to nature, but only to the existence or non-existence of a certain phenomenon. Then we need to know the difference between model and theory. Models and theories provide possible explanation for natural phenomena. A model can serve as a step-by-step formulation of a theory. So it's a step-by-step formulation of a theory. Theory can also be the basis of creating a model that shows the possibilities of subjects observed. Finally, model can be used as a physical tool in verification of theory. As we said, verification means it's a step-by-step to form a theory. Then we need to know the difference between theory and hypothesis. A theory predicts events in general terms, so it's generally on general terms, while a hypothesis makes a specific prediction about a specified set of circumstances. A theory has been extensively tested and is generally accepted, while a hypothesis is a speculative guess, so it's just a guess that has yet to be tested. So theory is tested while hypothesis is not tested, and it's just a guess or a suggestion. And there's an example for more illustration about how can ants move in a straight line. It's a beautiful example. So if we take each on this example, hypothesis. So several hypotheses has been made for this example, for how ants actually move in straight line. Several hypotheses have been proposed to explain the mechanism by which these ants are able to return to their nests or go away from the nests. One hypothesis was that the insects use visual landmarks to plot their courses. However, the territory surrounding their nests is often devoid of any features that could potentially serve as points of reference. It's just a suggestion. We don't know if it's true or false. It's not tested. It's just a suggestion. The suggestion that the ants use polarized light as a guide is contradicted by the observation that they are able to assess how far they have walked even in the dark. So this is another suggestion. So to prove this is right or wrong, so we need to build a model. So here comes a model on how ants move on straight line, which is called Boltzmann-Walker model, which describes an ant's random walk as a series of straight segments separated by reorientation events, and this model was extended to take directional influence into account. This extension allows us to test separately how average speed, segments length, and reorientation decisions are affected by support inclination and current walking direction of the ant. So now we have built the model for how ants move on straight line, Now, after testing this model several times and getting observations, we have made a conclusion or a theory from that. We found that support inclination had a major effect on average speed, which appeared approximately 3 times slower on the incline. However, we found no effect on the walking direction on speed. Contrastingly, we found that ants tend to walk longer in the same direction when they move uphill or downhill, and also that they preferentially adopt new uphill or downhill headings at turning points. We conclude that ants continuously adapt their decision making about where to go and how long to persist in the same direction depending on how they are aligned with the line of maximum declivity gradient. So this conclusion is our theory after many testing and observation. I hope the difference was clearly understood, and thank you for listening.